Hi friends, in this third video related to units and measurement, first we will understand why SI system of units is called a rational system of units or coherent system of units. Then we will come to the prefixes used to obtain sub and multiple units. After that we will learn about the non-metric units of length, mass and time. And then we will come to the measurement of length, and from the measurement of length we will learn about the first, that is determination of radius of atom using Avogadro's hypothesis. So be ready with your pen and notebook to pen down the important points for your future revisions. So first we come to the point why SI system of units is called a coherent system of units. This system of units is called a coherent system of units because in this system units of all physical quantities are obtained from the same fundamental units. Also, this system is called rational system of units because in this system of units every physical quantity is provided with a unique unit. Now we come to the prefixes used to obtain sub and multiple units. First three will be in multiples of 10, and after that multiples of 10 to the power 3. So first is deci. Deci means 10 to the power minus 1, and if we are saying decigram, then 10 to the power minus 1 gram, decimeter 10 to the power minus 1 meter, deciampere 10 to the power minus 1 ampere. It means these prefixes can be used in front of any unit. Say the second is centi. Centi will be 10 to the power minus 2, and centimeter, centigram, centisecond, centiampere, like that. In front of any unit you can use centi. Then is milli. Milli is 10 to the power minus 3, milligram 10 to the power minus 3 gram, milliampere 10 to the power minus 3 ampere, like that. After milli, next is micro. Micro means 10 to the power minus 6. After that it is nano. Nano is 10 to the power minus 9. Then is pico. Pico is 10 to the power minus 12. Picosecond 10 to the power minus 12 second. Picoampere 10 to the power minus 12 ampere, like that. Next is femto. Femto is 10 to the power minus 15. Then atto. Atto means 10 to the power minus 18. And then jepto. Jepto is 10 to the power minus 21. Then yocto. Yocto is 10 to the power minus 24. And we can see that the symbols of all these prefixes are represented by small letters of English alphabet. And here for micro the symbol is mu, and mu means a Greek letter. So Greek letter mu is used to represent micro. Now we come to the prefixes used to obtain multiple units, and those prefixes again first three will be in multiples of 10 and then in multiples of 10 raised to the power 3. First is deca. Deca means 10, decagram 10 gram, decasecond 10 second, like that. And the symbol of deca is capital D. Deci small d, deca capital D. Next is hecto. Hecto means 100, 10 to the power 2, hectogram 100 gram, hectometer 100 meter, like that. Now next is kilo. Kilo means 10 to the power 3, kilosecond 1000 second, kilogram 1000 gram, kilometer 1000 meter, like that. Now next is mega. Mega is 10 to the power 6. After mega there is giga. Giga is 10 to the power 9. Symbols of mega and giga, tera, peta, exa, zeta, yoto, all will be represented by capital letters, while that of kilo and hecto will be represented by small letters of English alphabet. tera is 10 to the power 12, and then peta 10 to the power 15, petameter 10 to the power 15 meter, petagram 10 to the power 15 gram, petasecond 10 to the power 15 second, like that. Now exa is 10 to the power 18, then zeta 10 to the power 21, and then yoto 10 to the power 24. It means using these prefixes we can obtain sub and multiple units of a physical quantity. Now we will come to the non-metric units. Now non-metric units of length. Among subunits, the first one is micron, and 1 micron means 1 micrometer. 1 micrometer is 1 micron, it means it is 10 to the power minus 6 meter, and micron is used to measure size of virus and bacteria. Next is angstrom, and 1 angstrom is equal to 10 to the power minus 10 meter, and this is the size of an atom. So angstrom is used to measure size of atom as well as wavelength of electromagnetic waves. Next is Fermi, and 1 Fermi is 1 femtometer. 1 femtometer means 10 to the power minus 15 meter, and this unit, that is Fermi, is used to measure the size of nuclei, because size of nucleus is of the order of 10 to the power minus 15 meter. Now we come to the multiple units, and among the multiple units, first will be astronomical unit. 1 astronomical unit is the average distance between Sun and Earth, and this average distance between Sun and Earth is 1.496 into 10 to the power 11 meter. Now the next is 1 light year. 1 light year is bigger than 1 astronomical unit, and 1 light year is defined as the distance covered by light in vacuum in 1 year. We know that distance is equal to speed into time. Speed of light in vacuum is 299,792,458 meter per second, and the time for which light travels is 1 year, and 1 year is 365.25 days, and 1 day contain 86400. So this will be 9.467 into 10 to the power 15 meter. So 1 light year can be easily calculated. Next bigger unit of length is parallactic second or parsec. To determine parallactic second or parsec, we will be requiring the definition of angle, as angle is equal to arc upon radius. Here angle should be in radian. Now how to define parallactic second? 1 parallactic second is defined as the distance at which an arc of length 1 astronomical unit subtends an angle of 1 second. It means if I consider that this body is Sun, this body is Earth, then the distance between these two bodies will be 1 astronomical unit. And if we will move away from these two bodies, then the angle subtended by these two bodies on our eyes will go on decreasing. And also we must know that angular limit of resolution of normal eye is 1 minute. It means if the angle subtended by two objects on eye is less than 1 minute, 1 by 60 degree, then those two objects will not appear to be separate to us. Here angle is once again, which is 1 by 60 times of a minute. It means this angle is much smaller than 1 minute. It means at this distance by normal eyes we will be unable to see the two objects separate. It means these two objects will merge into one another at a much earlier stage only, when the angle will be 1 minute. Now we can calculate the value of 1 parsec, but for that first we will have to convert this angle of 1 second into radian. We know that 1 degree radian, because 180 degree is pi radian, 1 degree will be pi upon 180 radian, and pi upon 180 into 1 upon 3600 radian. Now this is the angle, and angle is equal to arc upon radius, implies pi by 180 into 1 by 3600, that is angle, is equal to arc length, that is 1 astronomical unit, divided by radius, that is 1 parsec. This implies 1 parsec is equal to 1 astronomical unit, that is 1.496 into 10 to the power 11 multiplied by 180 multiplied by 3600 divided by pi, that is 22 by 7 or simply pi, and this will give us 3.08 into 10 to the power 16 meter. If we compare 1 parsec with 1 light year, then we will divide 3.08 into 10 to the power 16 by 9.467 into 10 to the power 15 meter, and this will give us 3.26 light years. So it was about the parallactic second, that is parsec, and relation of parsec with light year. Now we come to the non-metric units of mass. When we come to the subunit, then among the subunit is pound and 1 AMU, that is 1 atomic mass unit. 1 AMU or 1 U, because it is unified atomic mass unit, so sometimes it is represented by U also. So AMU or U both are same thing. And how to define 1 AMU? 1 AMU is 1 by 12 the mass of 1 carbon 12 atom, and we know that the atomic mass of carbon is 12. So if we will take 12 kilogram of carbon, then will form 1 kilogram mole of carbon, and 1 kilogram mole of carbon will have 6.023 into 10 to the power 26 constituent particles, that is 6.023 into 10 to the power 26 atoms of carbon 12. So mass of Na, that is Avogadro's number, mass of Na, that is 6.023 into 10 to the power 26 carbon atoms, will be 12 kilogram. So mass of 1 carbon 12 atom will be 1 by 12 into mass of 1 carbon 12 atom 12 kilogram divided by Avogadro's number, and Avogadro's number say is N, then this will be 1 upon N. If you will put the value of N in per gram mole, then this mass will come out to be in gram, but if you will put this value in per kilogram mole, then this will come out to be 1 upon 6.023 into 10 to the power 26 kilogram, and this will be perhaps 1.67 into 10 to the power minus 27 kg. Now the unit bigger than 1 AMU will be pound, and 1 pound will be 0.4536 kilogram. When we come to other multiple units, then in our local language we use a dhadi for 5 kilogram, a man for 40 kilogram, then a quintal for 100 kilogram, then a metric ton for 1000 kilogram, and still bigger units are Chandrasekhar limit. One Chandrasekhar limit is equal to 2.786 into 10 to the power 30 kg. Then one solar mass means mass of the sun, that can also be taken as the reference standard for measurement of mass, and one solar mass is 2 into 10 to the power 30 kg. Then we come to the non-metric units of time, and if we start from the subunits, then the smallest unit is 1 shake. 1 shake is 10 to the power minus 8 second. And when we come after week, a fortnight means the interval between 2 consecutive full moon day or between 2 consecutive no moon day, and that is approximately 14 days. After fortnight will be lunar month. Lunar month is equal to the time taken by moon to rotate once about its own axis or to complete one revolution around the earth, and that is 27.3 days. After lunar month will be month. Month is 1/12 of a year. After month there will be year, the interval in which earth completes one revolution around the sun, and after year is decade, interval of 10 years. After decade it is century, interval of 100 years, then millennium, interval of 1000 years. Now we are coming to measurement of length. Here we are considering only one measurement of length, and that is determination of radius of atom using Avogadro's hypothesis. There might be numericals related to this method of determining length. Say we are having the radius of one atom as R, Avogadro number n, molar mass of substance m, and volume of 1 gram of element as V. Then first volume of one atom will become 4/3 pi r cube, because radius is r and size is too small, that for that size no other shape can be considered. So we are assuming the atom to be a perfectly sphere, and then volume of one atom will be 4/3 pi r cube. Then volume of n atoms is equal to 4/3 pi r cube into n, and n atoms means m gram of atoms if we have taken molar mass in grams. Then this implies volume of m gram of atoms is equal to same that of n atoms, because m gram of element will contain n atoms. So this will be 4/3 pi r cube into n. If it is the volume of m gram, then volume of 1 gram of atoms will be n upon m into 4/3 pi r cube. But all volume possessed by element is not occupied by atoms only. It means some part of volume occupied by element remains vacant, and if we assume that 2/3 of the volume occupied by element is occupied by atoms, then volume occupied by atoms will be 2/3V. So 2/3 of the volume of 1 gram of element will be occupied by atoms. That is 2/3V is equal to the volume of 1 gram of atoms. That is N/m into 4/3 pi r cube. And this will give us R is equal to 3 will get cancelled, 2 to the 4. So V into M upon 2 pi capital M raised to the power 1/3. In this way, we can determine the radius of an atom, assuming that 2/3 of the volume of element is occupied by the atoms.